Hello, my name is Katie Lawson, and I will be going over or reviewing Chapter 5E, Parallel and Perpendicular Lines. So, some important symbols, meanings, and figures to know before we start is what parallel and perpendicular lines look like, what their definitions are, etc. So, over here we have the symbols for A, and then there will be two lines between the next letter, which is B. This means the line A is parallel to line B. And the symbol that parallel lines have, or the figure, is there will be one line here, and it will be marked A, and then another line exact opposite of it, which will be B. Now, perpendicular lines are the complete opposite of parallel lines. Their symbol is A, and then like an upside down T in between the B. So line A is perpendicular to line B. This will look like in a figure, a almost cross. Line A will be crossing line B. And yeah. For any pair of lines, there are certain requirements that must be met. For the lines to be parallel, the slopes have to be the same. For the lines to be perpendicular, the slopes are or have to be opposite reciprocals, meaning the first slope must be positive and the second slope must be the reciprocal but must be negative. And if lines are neither parallel nor perpendicular, neither of what I have just said is true. So I'll give you some examples of what I'm trying to say. So for example A, y is equal to 4x minus 1 and y is equal to 4x plus 5. The slopes of these two equations are both 4. So thus, since the slopes are the same, they are parallel. For the next one, we have two different slopes. And they have they are opposite to one another. This is the reciprocal. The second equation is the reciprocal of the first equation. And not only that, it is the negative reciprocal. So thus, these equations are perpendicular, or these lines are perpendicular to one another. Now the last one may seem like it is perpendicular, that these lines are perpendicular. However, since they are not opposite reciprocals, meaning since this equation's slope is not negative, as you can see it's lacking the negative, this means that it is neither perpendicular nor parallel. Applying what we just learned, let's now graph some parallel and perpendicular lines. To do this, we will use the equation at the very top of the whiteboard. Y is equal to 1 over 2x minus 1. We will graph a parallel line to that by using the point 1 and 2. To do this, we will use point slope form. Y minus y1 equals m times x minus x1. What we will do is we will plug in 1 and 2, our point, into point slope form. This will turn out to be y minus 2 is equal to 1/2 times x minus 1. and we would leave it be because, just because. Now we will graph this line. So we will go to the point 1 and 2, which would be right here. We'd go up 1 and over 2. That would be our next point. Our third point will be going down 1 and over 2. So 1, 2. Then we would draw our line. Draw that line a little better. As you can see, it's parallel. And how we did this is we used the rise over run method. So we went up 1 and over 2 and down 1 and over 2 to get our points. Thank you. To write the equation of a line that is either parallel or perpendicular to a given line, there are certain steps you need to follow. First, solve the comparison line for y, if not already. Second, find the slope of the comparison line. 3, decide on the slope you need for your line. Parallel will use the same slope. Perpendicular, however, will use the opposite reciprocal slope. Fourth, you have to write the equation in point-slope form using the point you were given and the slope you decided on in step 2. 5, if requested, change to the proper form of the line. There are 3 types of forms as we have already discussed: standard form, slope-intercept form, and point-slope form. Now we're going to solve some equations. So, by writing each equation in their requested form. Here we have an equation, 3x minus y is equal to -5. We are trying to solve for a comparison line for y, and it passes through this point, -2 and 1. So, we will solve for y. 3x minus y is equal to -5. We are going to subtract -3x to the other side. That'll be -y is equal to 5. Pardon me, -3x minus 5. Then we are going to multiply the whole equation by a negative because we want to get rid of that negative that's with the y. So that will turn this equation positive. And that will be our new equation. So let's figure out the slope of our comparison line. It will be 3 and 3 because we are trying to find a slope that is parallel. And to have a parallel line, you need to have the same slope. Now we must put it in point-slope form. To refer back, if you've forgotten, point-slope form is y minus y1 is equal to m times x minus x1. So we'll plug our numbers into this equation. Y minus 1 is equal to 3 times x plus 2. That will be our point-slope form equation. However, they asked us to put it in the requested form, which is slope-intercept form. Slope-intercept form is, of course, y is equal to mx plus b. So we'll just plug in our equations from there. But we have to do that via point-slope form. So we'll solve through this. So we'll distribute out this 3 to x plus 2, and that would be y minus 1 is equal to 3x plus 2. Then we will add our 1 over to our 2, and that will get us 3x, pardon me, y is equal to 3x plus 3. And that will be our final answer.